So hello everyone, and sorry for the delay. This is part 2 of chapter 11, and the math here gets really messy from now on. In fact, it's extremely messy. I showed you some equations in part 1, so now I want to show you some equations in part 2. Alright, so what they're doing now is there's 3 stocks. There are 3 stocks here, and we're going to combine risks. However, out of the 3, they're going to make portfolios of 2 out of the 3. So here's the stocks, okay? North Air, West Air, and Tex Oil. And here's the portfolio, okay? Half of North Air plus half of West Air. That's one portfolio. See that? Okay. And then the second portfolio is half of West Air plus half of Tex Oil. Okay. So we're creating portfolios. We're taking 2 out of 3. All right. Now, the easy part is the average returns. The average returns on all these are the same. You see that? 10, 10, 10, 10. Even the 2 out of 3. Okay. So how do they get the average returns? All they actually do, that's the easy part. You just take these 6 numbers, add them up, and divide by 6. Okay, so take these 6, divide, and add them up, divide by 6. So let's look here. 9 and 21 is 30, 37, 35, 30, 30 and 30 is 60. Divided by 6 is 10. So if you just simply do the add them up and divide, and then divide by 6, you'll notice even the portfolio comes out to 10%. However, the volatility now is not as straightforward. So what I want to show you is I used Microsoft Excel to get this volatility. Now, instead of putting the numbers in a cell, I was kind of real in a hurry. So I just took these numbers and I typed them manually into the function, okay? So let me bring up the Microsoft Excel function. First of all, hold on, let me close this for a minute. Now you'll notice the volatility is 13.4%, okay? So let me show you what function I used in Microsoft Excel. All right, so let me open this up. Now there's a function called STDEV, okay? Standard deviations. It's short for standard deviation. And we're going to use that to get the volatility. Now, as I said, I didn't put, as you can see, there's no numbers in anywhere around here. I just typed them in the cell manually. Okay, so I took those 6 numbers in the first column and I typed them in. And you can see that's all you have to do. And it gives you the 13.41 standard deviation, right? Or volatility. So I just said okay. I just said okay. And there it is. Now you could reduce, some of these decimals, right? Let's fix that a little. Number. All right, so this 13.42. All right, so I want to make sure everyone understands what I just did there. And that gives you this, okay? So, and we do that. You could do that for each one of these. And you should try this for each one to make sure it works. All right. All right. So, and you do the same thing with the portfolio, by the way. One thing you should notice is when you look at this portfolio, this first portfolio, and this second portfolio, you'll notice this one's got a larger volatility, right, than this one. So this has got less volatility. And it should be obvious just by looking at the numbers. You see a lot of negative numbers here. This swings from 25 to -3. This really doesn't have a lot of negativity. So this has less volatility. All right. So all right, so while the 3 stocks in the previous table have the same volatility and average return, the pattern of their returns differ. Now, did they have the same volatility? I got to go back and check that out. Hold on. Yes, they did. Everyone see that? Okay. So the volatility for all, now notice that, the volatility. So if you go in Excel and put all these numbers in, you'll get the same volatility. All right. I believe the way they did that is all the numbers are the same. So look, there's a 21 here, a 21 there, and a 21 there. 30, 30, 30. So you can see all the numbers are identical, right? And that's why the numbers came out the same. Okay, so for example, when the airline stocks perform well, the oil stocks tended to do poorly. And when the airlines did poorly, the oil stocks tended to do well. So when some were up, others were down, okay? I'm just trying to clean this up a little. All right, so consider the portfolio, which consists of 50% West Air and Tex Oil. The average return of the portfolio is equal to the average return of the two stocks, right? So we know that, right? However, the volatility of 5.1 is much less, as I just previously said, than the volatility of the two individual stocks, because they're basically one's camping off the other and they're diversifying out, right? When one is high, the other is low. So that's what portfolios are all about, right? So combining stocks into a portfolio, we reduce risk because we're diversifying, right? And you can see that. So the amount of risk that is eliminated in a portfolio depends on the degree to which the stocks face common risks and their prices move together. Okay, so trying to see what happened to my little record button here. Maybe I wasn't recording all this time. I don't know. So the big thing here is we're going to talk about covariance and correlation, which no one really ever likes to talk about, okay? For a lot of reasons, because it's a little difficult. So to find the risk of a portfolio, which we just looked at, one must know the degree to which the stock's returns move together. So if they both go up and both go down, they're going to be correlated and it's going to cause problems, right? So correlation is not too good a deal. We don't like things correlated, which is what in a portfolio you don't want too much correlation, right? For instance, you wouldn't want to buy all airline stocks, right? In this kind of environment that we're in now with the coronavirus. All right, so how do we get covariance and correlation? So I'll tell you what. Let me highlight this. All right. Bold. So this is covariance. And this is the covariance is the expected product of the deviations of the two returns from their means. So basically you got two returns here, right? And we're looking at how much they deviate from the mean. So we had RI and RJ here, right? So here's two examples. We have two returns. So what's the covariance between RI and RJ? We got to take the expected return of RI minus the expected return of RI. So you can clearly see there's a lot of expectations going on here, right? So we basically have the expected return, the return minus this expected return, and then this return minus this expected return, and then we multiply them, and I know this is difficult, and then we get the expected return of that, okay? So this is the covariance between returns, and there's a lot of expected returns here. All right, now there's a way of estimating the the covariance from old historical data, right? So we can take the covariance here, and we can use this equation here, and I believe this might be in Excel. I'm not sure. I'm going to have to go dig it up and look for it, all right? So the covariance is equal to 1 over the number of data points, the total number of data points minus 1, right? Times this return minus its mean, and this return minus its mean. Okay, so you can use either one of these to get the covariance. This one I believe is a little easier, right? So here's the important point. The important point is you don't want too big a covariance, right? If the covariance is positive, the two returns tend to move together. And that's not good for a portfolio, right? That's not good. If the covariance is negative, the two returns tend to move in opposite directions. And that's what you want in a stock portfolio, right? That's what you want. So you'd like this number to be negative, right? All right, I'm going to stop here because this is getting a little larger now, and I'll pick it up at 30. We didn't cover a lot of slides, but this is slow going stuff.